Hi everyone, today we're looking at Module 6, Lesson 12, and we're focused on nonlinear models in data. Our two targets say students give verbal descriptions of how y changes as x changes, given the graph of a nonlinear function, and students draw nonlinear functions that are consistent with a verbal description of a nonlinear relationship. So what we're going to do is look at the rate at which we can grow flowers. So we are going to be planting dahlias. And when we do that, we're going to try two different variables. We're going to look at using compost, which is like fertilizer, and not using compost. So I'm just going to set up my graph. I'm going to do my data table. So make sure you're filling this in. I'm looking at the week compared to the median height of non-composted flowers. So my weeks are going to go from 1 to 9, and then my heights go 9, 12.75, 16.25, 19.5, 23, 26.75, 30, 33.75, and 37.25. Then I just want to label my axis, x being 1 to 9. And my y-axis, I'm going to label in intervals of 5 so that I can get to a height of about 45. And I'm going to start plotting my points. You can do this independently. You can do it along with me. But as you plot your points, notice how this data is pretty linear, right? We're looking at a good straight line. And I'm going to trace my line to kind of demonstrate that. So the conclusions that we can see with this data is that we have a rate of change, and I'm going to choose 2 points to calculate that rate, the 1, 9 and the 730. Just because they're whole numbers, it's going to make it easier for me to get a slope of about 3.5. So when I think about whether or not this data is linear, my answer is yes, it is linear. Now we're going to think about the data if I did, in fact, use the compost or the fertilizer. So I'm going to do a second data table underneath, again showing weeks 1 through 9. And then including the median height. Starting with 1, I have 10, 13.5, 17.75, 21.5, 30.5, 40.5, 65, 80.5, and 91.5. And I'm going to go ahead and plot this data in green. So as I plot my coordinates, they kind of start out as linear, following that purple line. But now I'm starting to see those dots go up and almost off this grid into a little more of a curved pattern as opposed to a straight line. So one thing we can check is the rate of change. What is the difference between each set of points? So for example, the height of a plant after 2 weeks is 13.5 minus the height of the plant at 1 week, which is 10, gives us a difference of 3.5. So I'm just subtracting through to get 3.5, 4.25, 3.75, 9, 10, and 24. So we can see that this rate of change is not constant, which demonstrates that our data is not linear. Even though it's not linear, we can use both linear and nonlinear lines in order to predict the data. So just because that green line is curved doesn't mean it won't predict our outcome pretty thoroughly. So we want to think about which model, the non-compost or the compost, is best for growing the tallest dahlias. And by looking at your graph, you can see that the compost line, that green line, increases faster than the non-compost line. So when we use fertilizer, our flowers grow taller faster, which we can see in our graph, but also kind of makes sense in real life. If you were going to use fertilizer, your plants would probably grow better. Last thing we want to be aware of is that when data follows a linear pattern, there is going to be a constant rate of change, or a slope. However, when the data does not follow a linear pattern or follows a nonlinear pattern, the rate of change is not constant, so it's going to be a different value between all of our data points.